Hey guys, I am Holly. I'm here with Ronatiska, and we are talking more about geology today. So we're actually going to talk about the Earth and then actually what it's made of. So for a long time, scientists actually thought that the Earth was hollow because of, especially because of Isaac Newton's laws of gravity, but that is not the case. So we're gonna dive into the Earth and actually find out what is inside the Earth and how we know that that's there. So if you look at it, you can actually see the globe, and you'll see that the part that we see from space is actually, and the part that we live on, is water and land, but that's just a teeny tiny bit of what the Earth is made out of. We haven't even like scratched the surface, literally, of what this is right here. So if you think about the Earth, you can actually think about it in layers, like an onion, or an apple, where you have the core and then the flesh of the apple and then the apple peeling or skin, and then that is the actual Earth's crust. So let's go ahead and start from the inside of the Earth's core. Let me tell you a little bit more about the Earth and where it is as far as it's in space. So there's 4 terrestrial planets. There's Mercury, Venus, Earth, and Mars, and Earth is the only one that actually has something that's super important that sustains life, and that is chocolate. No, just kidding. That's water. So the Earth actually has water on the surface and also underneath in the crust. And then the Earth is also just about 13,000 kilometers in diameter. So it's a little bit larger than some of the other ones, but it's smaller than the other planets. So I'm going to put this down, and we're going to talk about some of the Earth's layers. So the Earth has that water, like I said, that makes it able to support life. The other thing that we have to support the life on the Earth is the atmosphere, and both of those are made possible by the magnetic field that exists. And the magnetic field exists because of the inner core of the Earth and what's actually down there. So if you think about the Earth, another way is like using an egg. I collected these this morning. So if you think about the shell, and then you have the egg white, that's kind of like oozy and liquidy. But then we also have the yolk. So the shell would actually be the Earth's crust. You can see that it's very, very thin. And then also something that's really cool is that when you break that egg shell, it can float. I'm sure if you've ever tried to make a cake or something and tried to get the eggshell that fell into your batter, it floats on top of the egg white. And so that is exactly how the Earth's crust works. So we're actually going to talk about the inside first, that core. So the Earth's core is actually made up of 2 different parts. So we have, I love archery, so that's the easiest way for me to explain this. I found this piece of scrapbook paper. So we have the inside of the Earth's core right here. All of that yellow, and I tried to make that yellow, but it just didn't work. So this is going to be the inner core. And then around the inner core is the outer core. Now, you may think, okay, well, what's the difference? Why does it make a big deal? It actually makes a really big deal. Like I was saying, it actually makes that magnetic field possible for us to be able to have our atmosphere and water. But the Earth's core is actually made of, this is really cool, it's made of iron, which I have a cast iron pan, and then also nickel, just like the nickels that we use. But it's different in the different parts of the core. The inner core is super, super, super hot, but it also is bearing all the weight of the entire planet onto it, so it has a lot of pressure. And then the outer core is also made of iron and nickel, but it doesn't have as much pressure on it So it actually is a liquid. So I don't know if you've ever been to a blacksmith forge and seen them melt the iron and turn it into different things, like this cast iron pan here. They had to melt that to form it into this. But on the inside of the core, because it gets so hot and there's so much pressure, iron actually stays a solid in the inside. So the inner core is very dense, and it's actually 1,200 kilometers thick, and it actually makes up about 10% of the Earth's radius. The outer core is about 2,200 kilometers thick, and it moves. It can flow just like something that's liquid, or something that floats on something else. So we also have, the core is the super hot temperatures of 5,500 degrees Celsius. It's way more than we can understand. So after you have that inner core and outer core, you have the mantle. And so the mantle is really important because it is, a lot of people think that it's super liquidy, kind of like that egg yolk or maybe chocolate pudding or something like that. But it's actually more like the consistency of melted plastic. So it's still a semi-liquid, but it's still a solid. But it actually moves, it just moves very slowly. So it's about 2,900 kilometers thick. It consists mostly of that liquid. And then in that mantle, that's where we have lava that flows through volcanoes. And then on top of that, we actually have the Earth's crust. Very thin layer. It is literally super thin. So in like places under the ocean, the oceanic crust, there's two types of crust, oceanic and continental. The oceanic crust are about 5 kilometers thick. That's on the bottom of the ocean floor. And then we have the continental, and that's actually 30 to 50 kilometers thick. So it's still so much thinner than the other layers of the Earth. So this right here is going to be our mantle, and then this little blue line around here is going to be our crust, and that's even enlarged to show way bigger than what we can imagine. Remember that eggshell. So now that we've shown you a little bit about that, another example that I have, one of my favorite candies, is an everlasting gobstopper. And if you bite through one, or if you kind of suck on it for a little while, it actually shows those different layers, just like the Earth's core. So we are actually going to make an Earth today, and then we're going to basically take a giant chainsaw and cut the Earth in half. So we're going to start with yellow. I've actually made some Play-Doh here from some flour. It's called salt dough. So it's just flour and salt and water. Super easy. I put some food coloring in there to show you the difference. I'm going to roll the inner core into a ball, if I can get it to stay in a ball. All right, so we've got our inner core. And then what we're going to do is have our outer core. And that's going to have to go around the inner core. So I'm actually going to flatten it out just a little bit. And then we're going to roll it up around there. Kind of pinch off the excess. Get him back in there. So now we've got the inner core and the outer core. Then we're actually going to put the mantle on. It's going to do the same thing. I'm going to flatten it out. And remember, this is actually where the magma and the lava, or the lava is actually magma after it comes out of a volcano. But this is where all of that hot plasticky type material is, and we're going to roll it in there, just like that. Pinch off that excess. Roll that into a ball, so we're getting bigger and bigger. Then we're going to do a very, very, very thin layer of blue, and we'll put some green in there just to show. So remember I said that the oceanic crust are really super thin, like 5 kilometers in places. So there are lots of underwater volcanoes as well. And then the continental plates are on top of that, and they're going to be thicker because we've got the earth, like we've got rock and mountains and stuff like that. So we're going to cover our Earth's ball with try to get it as thin as we possibly can. Now, those places like this where the magma is actually peeking through, those are really important. Those are actually where our earthquakes and our volcanoes come from, or those tinier pieces of crust, or we're going to talk about this in just a second, the plates that the crust is made out of. So let's just put some green around different places because I'm not going to be able to actually shape the continents. And we're not going to put very much green on there because the actual Earth's outer crust is made of 70% water. So that's not very much land on there. So now that we have our Earth ball, we are going to, if we were able to get a giant chainsaw and cut through the Earth's layers, you would actually be able to see there's the inner core, the outer core, the magma, and the crust. And so you can do that at home. Also, what we have, I'm going to show you an example of the Earth's crust. So instead of this being water, we're going to pretend that this is magma or that mantle. And the Earth's crust is actually like giant jigsaw pieces. And it floats on top of that mantle. And then they actually fit together just like a jigsaw puzzle. But because they're on water, you can see that they're moving around. Because they're on that mantle, they actually float, and sometimes they'll get stuck up under different pieces. They'll bang up against each other, and then sometimes they'll even start to disappear because one went on top of the other. And so when that happens, actually, when they collide like that, it can kind of fold the Earth's crust to make mountains. But it also, when they kind of rub up against each other, sometimes they stick. And then when they break apart, that's actually how we get earthquakes. So just a little bit of science on how the Earth is actually formed, what the inside looks like, and then this giant jigsaw puzzle that we live on. These tectonic plates only move at the same speed that your fingernails grow. So very, very, very slowly. But they do move, and then when they actually build up so much pressure, they can explode and turn into volcanoes. So that is today's lesson on what the Earth is made out of. I hope you enjoyed it. Have a good day. How many minutes was that? Because I felt like forever.